Fix my speech part. Where is my stupid pen? I had it and then ran off on me yet again. Here we go. Too many pockets. All right. So remember, guys, my molar mass, as you guys saw, was the sum of all the atoms present. So the biggest thing that I need to figure out my molar mass was my periodic table. So if I'm looking at beryllium fluoride here, I have one beryllium atom, I have two fluorine atoms. 1 times 9.01 grams. I take that straight from my periodic table. Beryllium, 9.01. I have one atom of beryllium in my compound, 1 times that. Because it's the sum, am I adding, subtracting, multiplying, or dividing all my values together? Guys, if I'm doing the sum of everything, am I adding, subtracting, multiplying, or dividing everything? I'm adding everything. I'm adding everything. So, plus fluorine. Let's take a look at fluorine here. Fluorine has the molar mass of 19. There's 2 atoms, so 2 times 19.00 grams. Close that off. Now, it'd be nice if I had my handy-dandy calculator, which I do. It's dandy, not too handy. Turn it on. Turn it on there, buddy. There we go. Clear, clear, clear. 1 times 9.01. Close parentheses, plus new parentheses, 2 times 19.00, close parentheses, enter. My molar mass of my first compound should be 47.01 grams beryllium fluoride. How'd you guys do on that first one? We feeling confident with that? We feeling good? John, you doing all right? All right. Iron 2 sulfate. I have 1 iron, 1 sulfur, 4 oxygens. Looking at my periodic table, iron has a molar mass of 5.85 grams. Add the next one, 1 times 32.07. Remember correctly off the top of my head, I am right. For the sulfur, plus 4 times 16.00 grams. For my oxygen. Now, here's the thing. I want you guys to get familiar with the process first. The second day we're working on this, yes, I know 1 times something always equals that something, right? 1 times 55.85 is always going to equal 55.85. Why am I bothering writing it out? Because I want us to link the process to it. As we do this more often, the faster you'll get with it. You may choose to skip the 1 times and just put the 55.85. But I want us to make sure that we understand the process that's going on. Because the moment I just start adding my values, I forget about the times 4 for the oxygen. Right now, follow the process. Yes, I know it's lengthy. Yes, I know it's redundant. But once we get it in our head, then we can find the shortcuts. Start with the long process, find the shortcut. So 7 plus 4 times 16.00. All right. That gives me 151.92 grams for my iron 2 sulfate. How are we feeling about number 2? Feeling good? All right, our last one. We got those parentheses. Now, clearly see I have 3 manganese atoms here. How many phosphorus atoms do I have? 7 of them, right? I have 7 phosphates. 7 times 1 phosphorus equals 7 phosphorus I have to count for. 7 times 4 oxygens gives me 28 oxygens. Be careful with that parentheses outside. It's going to affect all the numbers on the inside of my parentheses like we're doing an algebraic equation. 3 times the molecular weight is for manganese is 54.94 grams. So, because I got a bunch of them, I'm just going to label them real fast. Plus 7 times for phosphorus, 30.97 grams. That's my phosphorus. Lastly, my oxygen, 28 times 16.00 grams for oxygen is going to yield 3 times 54.94 plus 7 times 30.97 grams plus 28 times 16 gives me a molar mass of 829.61 grams for manganese 7 phosphate. How do we do? Okay? Más o menos? It's all right. Like I said, guys, second time we're doing it. It's the first time where I didn't walk us through an example before we just jumped into it. The first two I feel were the easiest one. The last one is going to be a little bit of a catchier one. Because if I forgot about the rule about the 7 on the outside of my parentheses, it was going to mess me up a little bit. Just keep that in mind. Now, let's take a look at the homework. Now, the thing is with the homework is I have the answers on my page here. So you can check your answers. And if you want to, we can go over a question or two. That your paper is not lining up very much with mine. We can take a quick look at it together. Walk our way through the equation. But I want you to check your paper and see if it lines up with mine. Now be careful when you are rounding your answers to the appropriate amount of sig figs. Leading zeros never count. So I have 4 sig figs here. 1, 2, 3, 4 sig figs in my final answer. Check our answers. I'll slide up so those in the back can see the bottom ones. Is there anyone that we want to go over? Ma'am? Yeah, that's fine. So you want to go over any of the questions? Number 3. Absolutely. So let me put it on the board here. So we want to look at number 3. Do I have another one that we want to take a look at? 1 through 10? I got 1 for 3. Going once. Going twice. Done. All right. Christian, is there one you want to go over? Nope. Okay. All right. So I'm on my white paper here. Let's rewrite the answer here. So I have 3.2 times 10 to the 25 molecules. Now notice that molecules, I see that up here as well. Molecules and atoms get interchanged pretty frequently. So I'm looking at Avogadro's number of hydrogen peroxide. And I'm trying to figure out how much I'd have to weigh to get that many molecules. All right. So in this situation, the first step I need to do is I need to rewrite all my equalities. Now, I know 1 mole of anything holds how many atoms or molecules? 1 mole. What's the number? What's it start with? 6. You're absolutely right. 6.022 times 10 to 23 atoms / molecules. Always the case. One mole always equals these many atoms. I also know, in order to get the molar mass in grams for H2O2, I have to write that out. There are 2 times 1.01, because it's H2, right? Plus 2 times 16.00, I'm going to put G there. Grams, 2 times 1.01 plus 2 times 16. Because my molar mass is 34.02. Can we please have the conversations pause while I'm talking? Be checking your work as I'm going through it. Now, if I had this equality written out every time, I can't go wrong. There's actually one more equality I can write out. 22.4 liters at STP. If I have these 4 equalities written out every time, there's nothing I can throw you in Unit 6, Unit 7, Unit 8 that's going to throw you off. Am I going to use all of these equalities? No. But if I get in the habit of writing out all 4 of these equalities, I can't miss. Step 2, I rewrite my problem. 3.2 times 10 to 25 molecules of H2O2. To make it easy, I put it over 1. Now I'm going to use my dimensional analysis equation. I want grams in my final answer. Which equality am I going to use to get grams up top? 1 mole, 6.022 times 10 to the 23 atoms, the molar mass in grams, or the volume of the gas at standard temperature and pressure? Moles, atoms, grams, liters. Which one goes up top? What do I want? Grams. My grams, 34.02 grams H2O2. What do I want to put in the bottom? Do I want to put mole, atoms, or liters? Moles. Not moles. I want this right here. Molecules. Atoms, molecules. 6.022 times 10, 23 molecules. H2O2. So, remember my rules about multiplying fractions. I multiply the numerators together, multiply the denominators together. 3.2 second. Remember, you want to hit the second button to get to the E here. E 25 times 34.02. Go give me some big number, but I'm not done. Divided by 1 times Avogadro's number, so it's going to be Avogadro's number, divided by 6.022 second E 23, enter. 1807.6 771504 grams. Is that my final answer? No. How many sig figs did I start off with? 2. How many sig figs can my final answer have? 2. 1,800 grams hydrogen peroxide. On the quiz, you will take next class. What would I expect to see for all 4 questions? 1, your qualities written across the top. Ladies, let's not keep the conversation going right now. Especially when we're detailing what you need to have on your paper, on your quiz you're taking next class. Our qualities need to be written across the top. Moles, molecules, mass, liters. The liters, what you picked up on the worksheet that you have. You need all 4 of them there. You need to rewrite your question. You need to set up your dimensional analysis fractions, equality fractions, and a rounded answer. Each question, there are only 4 questions. They are worth 10 points each. Just writing down 1,800 grams hydrogen peroxide will get you a point. The majority of your points come from this setup. I have to see the setup. And I'll tell you this. You also have to tell me what those numbers are. So you have to bring down the units. Because I just write 3.2 times 10 to the 25 what? Raindrops, cats, dogs, hairs that used to exist on Mr. Wiseman's forehead? I don't know what it is. I have to know what it is. You have to write it down. Because if not, it was worth 10 points. And you just wrote 3.25 times 10 to the 25 times 34.02 over 6.02 times 10 to the 23. You lost 3 points. At the most you could get at that point is 70% on that question. Every question is going to be written like this. Quality, rewrite the question, dimensional analysis, rounded answer. If it's not like this, you're losing points. Make sure you're coming correct. So you want to make questions about how we got here? Nobody? All right. Well, let's jump into the new stuff then. So, quick reminder, the quiz that you're going to see next time is all about the mole. We calculated moles with looking at elements, so single items that are on the periodic table, and also our compounds. That's what's going to be on the test. That's your 4 questions. Basically, go back, revisit these questions. That's why you're doing questions 11 through 18 tonight, because it's just more practice doing the same thing. But before we get started, I forgot to have you guys go over here and collect this. I need everyone to make their way over to the side here. You want to grab only one piece of paper today. You want to grab the percent composition worksheet. Everybody needs one. Come on down. Come get it. Ooh, man. The heart beating, the heart racing, and all of a sudden everything starts clicking.
So, when I do the second part, do you have to follow the exact field?
Yes. I expect to see that every time. because that's our dimensional analysis. Well, I want you to do it the way that I showed you.
Okay. It's just kind of confusing with that second part with the grams. It's fine.
Well, I mean, the trick is, so like with the grams, it's the same thing. So whatever I want to keep, I put it in that numerator, right? So I wanted grams, so where did I get it? I got the grams from right here.
I get
I
it.
just plugged it in there. I want to get rid of the molecules. I come back up to my quality. That's when I put that in my denominator, so these items cross each other out, leaving just the grams.
Alright.
Yeah.
It's just something I get.
That's fine. That's fine. It takes a little bit. So, what's up? Shanking is blah blah blah. When she gets back, it's on you. Sound good? So, today we are focusing on determining percent composition of our elements in a compound. We're going to get a percent composition, also called a percent by mass, of an element in a compound. And this is a formula that we're going to work with today. The mass of an element in a compound, so I'm looking at the molar mass of the element itself. I'm going to divide that by the molar mass of the compound, which we should all be very familiar with how to get now, because we just went over it. We did it last time. And I'm going to multiply that number by 100%. So this is the equations at the top of your page. This is the equation that we're going to use all day. Now, before I get started, I put down my calculator, and much like my brain, I've already lost it. Here we go. Boom. There it is. Give me a quick second. Let me show you what we're going to do with this. So we're going to do an example. If you want to write down your example on the back of your paper, I recommend it. So you can also remember the steps that we took. So we want to figure out what is the percent composition by mass of hydrogen in water, H2O. Now I know by looking at my periodic table and looking at my formula at the top of my page, I need to figure out what is the molar mass of my hydrogen, which I take a look at my periodic table. I can see that right there. It is 1.01 grams. 1.01 grams. But I need to determine the molar mass of H2O. So remember, we already went through a process with this. I have two hydrogens. So it's 2 times 1.01 grams of hydrogen plus 1 times 16.00 grams of oxygen. It's going to give me a total of 2 times 1.01. Well, you can get closer if you can't see. I don't think cutting a light off is going to change a lot, but I can. Give me a quick second. Let me try some. We'll see what happens. It's not as dark as it's going to get, unfortunately. I'm going to get. So, I got the molar mass of hydrogen straight from the periodic table. 1.01 grams. Where did I get that? I looked at my hydrogen box. 1.01. Boom. Easy. Snagged it right from the periodic table. Molar mass of my water molecule. I had to add up all the values that were there. Add up all the atoms. 2 times 1.01. That's my mass of my hydrogens. Plus 1 times 16.00 grams, that's the molar mass of oxygen, yielding me 18.02 grams of hydrogen. I have everything I need now to answer my question. Because my formula, I'm going to take the grams of hydrogen, divide that by the grams of my compound, which is H2O, and multiply that by 100%. So if I walk that out, that is 1.01 grams hydrogen divided by 18.02 grams H2O multiplied by 100%. So take my handy dandy calculator. Clear that out. 1.01 divided by 18.02 times 100%. Gives me 5.604883463%. Is that my final answer? No. I need to round to how many sig figs? 3 of them. 1, 2, 3. Is the 4 high enough to kick my 0 to a 1? No. Meaning that my final rounded answer is 5.60% of a water molecule is hydrogen. Excuse me. So first thing I had to do, I had to figure out my molar mass for the item in question. Oh, you know what? I've made a mistake. I made a small mistake. How many hydrogens are in water? 2. I gotta account for that. I'm glad I came back and looked at this. That's gonna change my answer. That's grams. Because I have 2 hydrogens, it's 2 times 1.01. Divide that by 18.02 times 100. 11.20976693%. So follow 3 sig figs. My final answer is 11.2%. I apologize about that. I made a small mistake. I made a small mistake on that one. That's on me. Because there are 2 hydrogens in my atom, I have to account for both of them. I am dumb. I apologize about that one, ladies and gentlemen. A water molecule consists of 11.2% hydrogen. My bad. But how about I give you guys a chance to work on one? It should be a little bit easier. I want you to tell me what is the percent composition of iron in iron 3 chloride. I want you to take a stab on this and put it on your whiteboards. Ooh, man, that was dumb of me. Hello? Jasmine Torres for early dismissal. I'll send her down right now. Bye now. All right. When the music stops, we'll review it together. But you want to try it on your whiteboards. Calculate your molar mass of your compound. Divide the molar mass of your element by said compound. Multiply that by 100. Jasmine? Okay, I got good news. I got the bad news is that you gotta go. The good news is you're already doing the homework, so you're ready. So we're recording this right now. So you want to put this up on your end. Take next class. But
to understand what's going on for if you're with your gains.
Absolutely.
There you go.
Sorry, no.
Oh, you're absolutely right.
I'm not trying to do
No, I didn't think you were being rude. At no point in that that you're being rude.
All right. All right, guys, show me what you got on your whiteboard. Let me see what you did. Let me see what you did. See what you did.
All right, all right, all right. Okay. All right, we're getting there. All right, so set it up well, There we go. Beth, I didn't see you.
I did mine on the back.
Oh, and you did it in red ink. It's orange. Oh, I'm colorblind apparently. All right. So what you got for me? Oh, good work. All right.
Looking good, ladies and gentlemen. All right. So, gentlemen, give me a quick second. So, molar mass of my iron pulled out directly from the periodic table. For the compound, I'd work a little bit harder on it. 1 times 55.85, close parentheses, not times, that's plus. 3 times 35.45, close it off, boom. So I have 162.20 because remember, fewest amount, when I'm adding, fewest amount of decimal places, right? So I have 2, so that means I have to have 2 decimal places at the bottom. 55.85 grams iron divided by 162.20 grams iron 3 chloride. Multiply that by 100%. 55.85 divided by 162.20. Multiply that by 100%. Gives me an unrounded answer of 34.42799901%. Is that my final answer? Now, how many sig figs is my final answer going to have? 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. Always take the lowest, right? 1, 2, 3, 4. Boom. That 2 is not high enough to change that 3 to a 4, so my final answer is 34.43% of iron 3 chloride is iron by weight. This is going to come in super duper handy when we get to stoichiometry in Unit 8. Unit 7 is going to be about balancing our equations. All we're going to be doing is making sure that the amount of an element on one side of the equal sign equals the other side. But we are in good shape, ladies and gentlemen. Good shape. All right. So now I want to ask you to give me the percent composition of 3 elements on your classwork. Number 1, determine the percent composition of each of the following compounds. You're going to give me the percent composition for potassium, manganese, and the oxygen. I'm going to give you 5 minutes to work on it. When the music stops, we're going to go over it. You're going to do it on your paper now. This is question number 1 on your handout. Question number 1 on the handout. That's fine. Oh, wait. No.
What's up? Trailing is good.
Because the decimal place is there, you count. Remember, so leading zeros never count. Tailing zeros only count in the decimal place. All right, guys. So, you had a chance to answer it. What I'm going to do, I'm going to walk you through how I would attack it. I want you to check your answers with mine. So, I know potassium, straight from my periodic table, gives me 39.4, is it 4? 1, dude. 10 grams. I only have one of those, so that's all I need to do for that one. Manganese is over here, 54.94. Let me push it up a little bit. 54.94. 54.94 grams. For oxygen, how many oxygens do I have? How many oxygens do I have, guys? 4 of them. 4 times 16.00 grams. 4 times 16. 64.00 grams. So, I'm going to take all these numbers, I'm going to add them up. Plus 54.94 plus 39.10. Molar mass of potassium manganate is 158.04 grams. So to figure out the percent of potassium, I'm going to have, so at the end, I'm going to have 3 different equations. One for potassium, one for manganese, manganese, and one for oxygen. 39.10 grams divided by 158.04 grams. Multiply that by 100%. So 39.10 divided by 158.04 times 100. I'm going to get, guys, we okay back there? 24.74 0.57201%. I know that's not my final answer. I look back at my equation. I see that my least amount of sig figs is 4. 1, 2, 3, 4. Potassium makes up 24.74% of my compound. Would I do the same thing for manganese? Wait a second here. Push that over. Come on, stop being like that. Percent Mn equals 54.94 grams divided by 158.04 grams times 100% equals 54.94 divided by 158.04 times 100 gives me a total of 3,476,335,105%. I know it's not right. I go back and look at my question. 4 sig figs. Final answer, you can only have 4 sig figs. Therefore, percent manganese is 34.76% of my compound. Last one, oxygen.
Can I go to the restroom and
When the go comes back, for sure. I'm going to grab the 64.00 because that's the 4 times 16, right? There's 4 oxygens. I got to count for all of them. 64.00 grams divided by 158.04 grams times 100%. 64 divided by 158.04 times 100 gives me 40.49607.694%. Can't work with that. I got too many sig figs in my answer. I only have 4 over here. Therefore, my final answer can only have 4. Because of the 6, that's going to bump this up to 40.50%. If I add that up, 40.50 plus 34.76 plus 24.74, I get 100%. I can check my math and make sure that they all add up to 100%. That's how I know I did my math right. Now, do be mindful is that there may be a time where you may get a little bit less, like 99.9%. That's okay, because remember, we're rounding. But you should be right around that 100% every time. Here's 3, 2. Bam. All right. So I want you to take a stab at the other questions. Questions 2 through 5. Now, here's when I'm going to hit the stop button because I don't need to record this. Well, no, I should probably keep it going. So that's why we can go back and review some of the questions together. So I'm going to give you guys, I'm going to give you more than 10 minutes. I'm going to give you like 15. When the music stops playing, that's when we're going to check we're going to pause. We're going to take a look at the answers. Well, I want you to try the answers 2 through 5. But everything else is laid out right. We just have to change that division to multiplication. Right. Who is that? You know who exactly it is. It's probably. Add a little more time to this. 10-minute timer. Here's one right inside. What do you think, guys? Tomorrow's going to be 2 hours late? Freezing rain is supposed to come out to this. It's supposed to snow. And then tonight, it can go to freezing rain. And then if the weather channel is to be believed, it's not supposed to stop freezing raining. Well, the percentage of freezing rain doesn't drop down below 50% until like 6 o'clock in the morning. I mean, you ever hear the term batting 400? In baseball, batting 400 is supposed to put you up there with the all-stars. And what that means is 40% of the time that you walk up to the plate, you hit the ball. If an all-star in a baseball game hits the ball less than half the time it goes up there, you can't expect the weather people to get it right every time either. I'm saying that I'm at the top of my game, that 40% of the time I walk up to the bat, that I'm able to hit the ball. Not be able to get to base, just hit the ball. 40% of the time, that's considered up there as one of like the best hitters around. 40%. Which just proves that everything comes down to math and statistics.
even sports is just math. Then you start getting like RBIs and it hits the base. That's a whole different thing.
Yeah.
How many bases you can get every time you go to hit the bat.
That's one of the. I think what was it, Moneyball? Not Moneyball. That's
Moneyball sounds like it.
Yeah.
All right, guys. How many of you guys are still working on? I see some. All right, I'll give you guys another couple minutes. And then what I'll do is I'll put the answers up on the board so you can check to see how you did.
I can wait. All right, guys. Let me steal your attention to the front. So, I have the first set of answers on the board here. So, we have our hydrofluoric acid. We break it down to our different components. We add everything together. We get 20.01 grams of hydrofluoric acid. I take my molar mass of my hydrogen, divided by the compound, multiply that by 100, I get 5.05% of hydrofluoric acid is my hydrogen. If I look at the fluorine, 19.00 divided by 20.01 times 100%, 94.95%. If we sit there and do the math, everything should add up to about or around 100%. So you're looking at me, we're looking crazy. It gets a little busy there in the middle, I know. Which one are you not catching on? Number 3. All right. So do you remember with number 3 here? Let's slide it up a little more. With number 3, we got that it's magnesium nitrate, right? So that means I need 2 nitrate atoms here to cancel out my charges. So because of that, it's 2 times 1 nitrogen gives me 2 nitrogens. 2 times 3 oxygens gives me 6 oxygens. So be careful with that. It catches some people sometimes. And I only have 1 magnesium atom there. So I do my math. I come over here. I set everything up. Percent magnesium, get around 16.39%. Nitrogen, it gets around 18.89%. Oxygen, 64.72%. Remember, if I add all these numbers together, 18. No, they'll still equal 100. Just eyeballing it. No, that's just your classwork. So that has your notes on it. That has practice for what we're going to do later. So the homework was you're finishing the mole problem one. You already took that 11 or 18. So I want you to go back and make sure they're on mental analysis page. Right along the back. Okay? Because that's the sound we're really looking for when we do the quiz next time. We're going to start with the quiz and then move on to the rest. No problem.
So, ladies and gentlemen, always remember when it comes to those parentheses, because I will tell you on the quiz, there will be some parentheses ones that you're going to have to work with. Make sure you remember, it's like an algebraic equation. If my whole number is on the outside of my percentage, I have to distribute that whole number to everything in that in that parentheses. 2 times 1 nitrogen gives me 2 nitrogens. 2 times 3 oxygens gives me 6 oxygens. Same thing if I look down at number 5. Aluminum sulfate. I gotta distribute that 3. 3 times 1 sulfur equals 3 sulfurs. 3 times 4 oxygen equals 12 oxygens. Be mindful of it. We add them all together, boom. We knock out our percents. You want to make sure you are knocking out questions 11 through 18 on your homework.